In the previous video, we went through two fairly simple examples of how we can compute arithmetic series, the sum of several terms of an arithmetic sequence. This video is just some more examples of that, some more complicated examples. These are definitely not, this is not an exhaustive list of examples. There are other questions that can be asked. These are just a few examples of other things. I decided to write down here the three formulas that you will and may need for these problems. You should already have those in your notes from the previous videos. But here they are in case you need to see them again. So let's get to that first example. So the first one, I want us to find the sum of the numbers 1, 4, 7, 10, all the way up to 334. I think the thing that I want to remind you of is that, when you're dealing with a sum, remember there are two formulas. The first formula requires that we have the first term, the common difference, the number of terms, and the nth term. Those are the three things that we need. So we need the first term, the number of terms, and the nth term. The second formula requires that we have the first term, the number of terms, but this time the common difference. And so I think it's sort of important for us to pay attention to which formula do we want to use, which one sort of fits the problem. In our case here, we know what the first term is, we know what the last term is, and we can actually pretty easily figure out what the common difference is. So in both cases, what we're missing is we're missing the number of terms. We need to figure out how many terms there are. Right? In order to do that, we're actually going to fall back on one of the previous formulas. Because every sum is sort of a sequence behind the scenes, we know that we can use the formula that un is equal to u1 plus n minus 1 times d. Now, if you don't see it for yourself, I'd kind of recommend you pause the video and think about how this formula is going to help you figure out what n is. Hopefully you recognize, if I put 334 here, I can put u1, that was 1. I can leave this as n minus 1 because I don't know what n is, and then I just have to multiply by the common difference. Well, we can tell by looking at this thing that the common difference is 3, right? So if I solve this, I'm going to end up with 333 equals n minus 1 times 3. That means 111 equals n minus 1, so n is 112. So there we go, and this isn't our answer, this is just sort of a part of the picture. We now have that one, and in some sense we have information to use either one of the formulas. So it's kind of up to you as to which one you want to use. Personally, I've kind of always been partial to the first one. It's the one that I learned first. I actually never saw the second one until I started teaching IB. So I'm more familiar with this one, I have more experience with it, so I'm going to generally tend to use that one. So when I do this one, let's see here, we just found out that it was the 112th term. My first term was 1, my last term was 334. So if I simplify all this stuff, and I just realized when I wrote Sn here, I really should have written S112, because now we know that that's what we're looking for. Let's see here, this is 56 times 335. Presumably we'll use a calculator for that. So I got this sum to be 18,760. Hope my calculator's not messing with me there. Nope, that's it, and we're done with this problem. So that is the sum of all of those numbers. Now let's go on and look at that next example. This problem is actually quite similar to the previous problem. So if you're up for it, I'd say start it right now. Like, just try this problem on your own. It's really very, very similar to the last problem. I want you to find the sum of all the even integers between 2 and 100, including 2 and 100. Now, if you haven't paused it yet, or if you haven't figured it out, it may be helpful for you to think about what this means. This means they want you to do 2 plus 4 plus 6 plus all the way up to 100. Which means, if you remember, this problem is literally just like the last problem. The last one started out asking about 1 plus 4 plus 7 all the way up to 334, I think it was. If you follow the steps we did in the previous problem, it should work fine for this one. So hopefully you've worked through it and you've tried it on your own. Let's see what we know here, what we need. We need to figure out what number term this is. So I'm going to fall back on my un equals u1 plus n minus 1 times d formula. So I know 100 is equal to the first term plus, I don't know what n is, times the common difference. Again, just by looking at this problem, we can tell that you're adding 2 each time, so the common difference must be positive 2. This gives me 98 equals n minus 1 times 2, dividing by 2, 49 equals n minus 1, so n equals 50. And you may have been able to tell that, like you're like, oh, I can tell that's going to be the 50th term. That's great. I could have written another problem where it was harder to see that, so make sure you also understand where that came from. That's fine if you see other ways to get through problems, and lots of times I'm excited about us seeing other ways through problems, but we also need to know sort of how we can work through ones that may be more complicated. So just be aware of that. So great. I'm looking at this thinking, I have my first term, I have the common difference, I have the last term, I have n. Just like last time, I'm a fan of using that first formula. I'm a fan of using Sn equals n over 2 times u1 plus un. I could use the other formula, but I like this one better. It's shorter, I feel like it's quicker. So I'm going to use that one. So the sum of the first 50 terms is 50 over 2 times 2 plus 100. This gives me 25 times 102. So that means the sum of the first 50 terms is 2550. And there you go. That's the sum of the even numbers between 2 and 100. So another problem fairly similar to the previous one. The last one that I have is going to be a bit different, so hopefully you'll be up for that challenge. Alright, so you're told that the 71st term of an arithmetic sequence is 61, the 75th term is 73. They wanted you to find the first term and the common difference of the sequence, and then find the sum of the first 50 terms of the sequence. This one is probably frustrating, because if you remember back to what I said before, one of the formulas requires the number of terms, u1 and un. One of them requires the number of terms, u1, and the common difference. In this case, we only know one thing. All we know is we know the number of terms. And I'd recommend, pause the video and think about it. What number of terms am I most interested in this problem? Hopefully you see that it's 50. You're interested in n being 50 because that's what we want to find the sum of. Ultimately, we want to find S50, which means I'm going to have to use that n is 50 at some point. Right? But I don't know what any of these things are. I'm going to have to use the other information to do that. And this falls back on what we saw in some of the previous videos, right? I think the first video in the sequence, right? Notice there were multiple values of n here. They also talked about the 71st term. They talked about the 75th term. And in the first video in the sequence, I mentioned the idea that if they give you 2 different values of n, it generally means you're going to need 2 different formulas. We'll do one when n is 71, one when n is 75. The other point that I want to say about this problem is that IB does this a lot. They lead you through the problem. The first thing it says is find the first term and the common difference. Right? They want you to find the first term and the common difference. We've seen problems like that before. When you need to find both of those things, it's that system of equations thing. Right? So if we have n equals 71 and n equals 75, let's try and set these up. Remember we have that formula that un equals u1 plus n minus 1 times the common difference? And I really, really would strongly recommend you pause the video and think about how you can use that in conjunction with these 2 things to solve for things. So hopefully you did that. I've got 71. I'm sorry, not 71. I have u71, the 71st term, is equal to the first term, which I don't know, plus 71 minus 1 times the common difference, which I don't know. Right? I can refine that more. I know what the 71st term is. It's 61. So I can say 61 is u1 plus 70d. Over here, I can say u75, the 75th term, is the first term plus 75 minus 1 times the common difference. Right, so again, 75th term, I know that's 73. 73 is u1 plus 74d. And here, I'm in this position where I have 2 equations with 2 unknowns. This is really, really nicely set up for me to do a little elimination. So 61, u1 plus 70d. We can subtract equations here. I'll end up with 12 equals 4d. Great, that means d has to be 3. Now that I have that, I can sort of plug it back in over here. 61 equals u1 plus 70 times 3. 61 is u1 plus 210, which means u1 has to be negative 149. Great. So now I have my first term, I have my common difference, and we even have n, right? I mean, if we go back and take a look at the statement of the original problem, right? They want the sum of the first 50 terms. If I use the formula that needs the number of terms, the first term, and the common difference, I'm ready to go, right? So that formula was the sum of the first n terms is n over 2 times 2u1 plus n minus 1 times the common difference. So I just got to plug this stuff in. Sum of the first 50 terms will be 50 over 2, 2 times negative 149 plus 49 times 3. And this is one of those places where this will be a calculator problem. So S50 is negative 3,775. And that's our sum. So I hope those problems made sense. Like I said, I think that the thing that's most challenging about these problems is that there really isn't one straight path through the problem. You kind of have to look at them and figure out what pieces you have, figure out which pieces you're needing, and use the formulas to work through them. So, these problems are going to be all about the practice. Please make sure that they make sense to you and that you're getting them.